Good morning everyone. Welcome back to grade 5 mathematics class. Today we are beginning a new chapter, chapter 3, factors and multiples. Now, what are factors? We can say factors are the numbers that can divide a given number completely. That means without any remainder. See, here are some examples. Look at this number 6. We know 6 can either be 1 into 6 or 2 into 3. So we can say the factors of 6 are 1, 2, 3 and 6. And see, if we divide this given number, the number 6, using its factors, is there any remainder? We can completely divide those two numbers. See, what is 6 divided by 1? 6 divided by 1 is equal to 6. And what is 6 divided by 6? 6 divided by 6 is equal to 1. So, there is no remainder. It's complete division. This one also, 6 divided by 2 is 3 and 6 divided by 3 is equal to 2. So, the factors of any number can divide the given number completely without any remainder. Similarly, here we have the factors of 12. 12 can be 1 into 12, 12 can be 2 into 6 or 12 can be 3 into 4. So we say the factors of 12 are 1, 2, 3, 4, 6 and 12. Now, do you see some common factors for 6 and 12? See, this 1, 2, 3 and 6. This 1, 2, 3 and 6 are common to both these numbers, right? 1, 2, 3, 6, 1, 2, 3, 6. So, we say the common factors of 6 and 12 are 1, 2, 3 and 6. And which is the highest or the greatest among these factors? It is 6, right? So, we say the highest common factor or HCF of 6 and 12 is equal to 6. In your textbook, it's given 3 is the highest common factor. That's not the right one. Actually, it's 6. Further into this chapter, in our later classes, we'll learn more about HCF and the different methods of finding HCF of 2 or more numbers using its prime factors. Okay? Now, talking about factors, factors can either be prime or composite. Now, what are prime factors? Prime factors are prime numbers. We have learned about prime and composite numbers in our lower classes. Now, prime numbers are the numbers which have only two factors, means the number itself and the number 1. So, what does that mean? Here you have some examples. See, the number 2. How do we get 2? 2 is equal to 2 times 1 or 1 times 2, right? Do we get 2 by multiplying any other number? No. So, the only factors of 2 are the number itself and the number 1. So, we say 2 is prime. 2 is a prime number. What about composite numbers then? Composite numbers are the numbers which have more than 2 factors. See this example, 6. 6 is equal to 2 into 3 or 6 is equal to 1 into 6. So, it has more than 2 factors. The number itself, the number 1 and 2 and 3. So, it has more than 2 factors. So, we say the number is composite. Clear? Now, coming back to our previous example, we know 6 is equal to, 6 can be written as 1 into 6 and 12 can be written as 1 into 12. See this 6 and 12. These factors are composite factors, right? We can break down these composite factors again so that we can express these numbers in terms of its prime factors alone. Any composite number can be expressed as the product of 2 or more prime numbers. See this one? Here, the 6 can be broken down again into 6 equal to 2 into 3. So, here we can write 6 is equal to 1 into 2 into 3. Similarly, 12 can be written as 1 into 2 into 2 into 3. Where this 12 was first broken down into 2 into 6, and again the 6 was again broken down into 2 into 3. So now you see these two numbers 6 and 12 are represented as the product of its prime factors alone, right? Remember this number 1. 1 is considered neither prime nor composite. So the common prime factors here are the number 2 and the number 3. So the common prime factors of 6 and 12 are 2 and 3. Now, that was about factors. Now see multiples. So what are multiples? Multiples of a number are the numbers we get by multiplying the given number by 1, 2, 3 and so on. See this example. Here the number 3 is multiplied by 1, 2, 3, 4 and so on. And you get the answers here, and these numbers here are the multiples of the number 3. Clear? So we say the multiples of 3 are 3, 6, 9, 12, 15, 18 and so on. Now, here we have one more example. Now, multiples of 2. Which are the multiples of 2? Multiples of 2 are 2, 4, 6, 8, 10, 12 and so on. And the multiples of 3 are 3, 6, 9, 12, 15, 18 and so on. You see, there may be some numbers or multiples which are common to the number 2 and number 3. Do you see any such number here? Any such multiple here? Look at this one, the number 6. The multiple 6 is common to both 2 and 3. Now, what about this 12? This multiple 12 is also common to 2 and 3. So we say the common multiples of 2 and 3 are 6, 12 and so on. You'll get infinite number of multiples as you proceed, as you multiply with more numbers, and there may be more common multiples to this 2 and 3. Now, these are the common multiples here, and which is the least or the lowest common multiple of this 2 and 3? It is 6, right? So we say the least common multiple or the lowest common multiple or LCM of 2 and 3 is equal to 6. I hope this is clear to you. Now, we'll see some divisibility rules. What are divisibility rules? It means to check if a given number is divisible or if it can be divided by another number, we can apply some rules to the given number without actually dividing it. So it helps us in the division process. We know all the numbers are divisible by 1, right? So let's start with the divisibility rule of 2. So how do we check if a number is divisible by 2? We know all the multiples of 2 end in either 0, 2, 4, 6 or 8. So if the digit in the ones place or the ending digit of any given number is either 0, 2, 4, 6 or 8, we can say it will be divisible by 2. Or if it's an even number, the number which we are given, if it's an even number, we say it will be divisible by 2. See these numbers here, 5840, 5840 and 22. This one has 0 in the ones place and this one has 2. Both these are divisible by 2 or multiples of 2. So we say these numbers are divisible by 2. Now let's see the divisibility by 3. So what is the rule for that? If the sum of its digits is a multiple of 3, means suppose you are given the number 39. You want to see if it's divisible by 3. What do? You take the sum of the digits. For 39, when you take the sum, it's 3 plus 9 and you get 12, right? Is this 12 a multiple of 3? Yes, we know 3 4s are 12, right? So since this 12 is a multiple of 3, we can say this 39 is also divisible by 3. Very simple. Now, let's see the next rule, divisibility by 4. It says that if the number formed by its last two digits is divisible by 4, we can say the given number will be divisible by 4. See, it's a 3-digit number here. And which are the last 2 digits? The last 2 digits are 6 and 4. So the number formed is 64. Let's see if 64 is divisible by 4. 1. And you get 2 here. We know 4 6s are 24. See, the 64 or the number formed by the last 2 digits is completely divisible by 4. So we can say the given number 464 will be divisible by 4, the whole number. See, since this is a 3-digit number, you won't feel it's giving much help. But what if it was an 8-digit or 9-digit number? You don't really have to do the whole division. Just check the last 2 digits and make sure it's divisible by 4. If that's the case, the whole number will be divisible by 4. Let's see the next divisibility rule. If the digit in its ones place is 0 or 5. We know all the multiples of 5 end in either 0 or 5, right? 1 5 is equal to 5, 2 5s are 10, 3 5s are 15, 4 5s are 20. So all the multiples of 5 end in either 0 or 5. So just check the digit in the ones place. If it's either 0 or 5, you can say the number will be divisible by 5. Now, let's see the divisibility by 6. If the number is divisible by both 2 and 3, the given number will also be divisible by 6. We know 6 is equal to 2 into 3, right? So, if the given number is divisible by both 2 as well as 3, it should be divisible by both 2 and 3. Then it will be divisible by the number 6 as well. Now, in this case, in this example, 1, 2, 3, 6. Is it divisible by 2? Yes, it ends in 6, which is an even number. So, it's divisible by 2. Now, what about the divisibility by 3? Let's take the sum of the digits. 1 plus 2, 3. 3 plus 3, 6. 6 plus 6, 12. So, 12 is a multiple of 3. So, it will be divisible by 3 as well. So, the number will be divisible by 6. Now, let's see the divisibility by 8. So, if the number formed by the last 3 digits is divisible by 8. See, what is the number formed by the last 3 digits in this example? It's 864. Let's see if 864 is divisible by 8. You know, 8 tens are 80. 8 eights are 64. So, yes, 864 is completely divisible by 8. So, we can say this whole number 1864 will be divisible by 8. Like I said before, since this is a 4-digit number, you won't feel it's giving much here. But if it was a 7-digit or 8-digit number, you don't have to do the whole division. Just check the last 3 digits and see if it's divisible by 8. If it is, the whole number will be divisible by 8. Now, what about the divisibility by 9? If the sum of its digits is a multiple of 9, then the number will be divisible by 9. So, in this case, what is the sum of the digits? 2 plus 9, 11, plus 7, 18. Is 18 a multiple of 9? Yes, 2 9s are 18. So, since 18 is a multiple of 9, we can say this number 297 will be divisible by 9. Now, divisibility by 10. We know all the multiples of 10 end in 0, right? 1 tens are 10, 2 tens are 20, 3 tens are 30 and so on. So, if the digit in the ones place, the last digit is 0, you can say the number will be divisible by 10. I hope these rules are clear to you. Now, divisibility by 11. How do you check the divisibility by 11? If the difference between the sums of alternate digits of the number is either 0 or 11, then it will be divisible by 11. What does that mean? You have the number here, an example, 1232. If the difference between the sums of alternate digits means these are the alternate digits 1 and 3 and 2 and 2. The sums of alternate digits. 1 plus 3 is 4, 2 plus 2 is also 4. Difference between the sums of alternate digits. So, it's 4 minus 4. What is it? It is 0. So, if that difference is either 0 or 11, then the given number 1232 will be, or any other number, will be divisible by 11. So those were the divisibility rules. We'll see one question now. Replace hash in 273 hash by the smallest possible digit such that the number formed is divisible by 3. So what was the divisibility rule for 3? It says that the digits of the given number, the sum of the digits of the given number should be a multiple of 3. Then the given number will be divisible by 3, right? So in this case, you're asked to find out what number comes in place of this hash so that the number becomes divisible by 3, right? So let's first take the sum of the digits. So it is 2 plus 7 plus 3 plus hash. We get 2 plus 7, 9 plus 3, 12 plus hash. It should be a multiple of 3, right? This 12 is already a multiple of 3, right? We're asked to find out the smallest possible digit that can come here, right? So what is the smallest possible digit that can come here so that this 12, which is a multiple of 3, won't change? It must be 0, right? So if 0 comes here, 2 plus 7 plus 3 plus 0, the sum remains 12 itself, right? Which is a multiple of 3. So the smallest possible digit that can come in place of hash is 0. So the number will be 2730. I hope this is clear to you. So as the activities for the day, you have to go through the pages 36 to 39 in your textbook. You have to finish the exercise 3.1, and after that, below exercise 3.1, you can see one question like this and another set of questions. Go through all these questions and do accordingly. That's all for today. We'll meet in the next class. Until then, bye.